React has two fundamental rules of hooks. Only call hooks at the top level. Only use hooks from React functions. You know them. You respect them. Break these rules, you might just break your app. But do you know why that is? Hi, everyone. I'm Charlotte. I'm a React Native tech lead at BAM. And today, we are going to break React rules of hooks to aim a better understanding of React. So let's begin with the first rule of hook. Only call hooks at the top level. So we're not going to do that. We're going to use a hook conditionally. Inside a recipe example, a recipe that for now only contains a single ingredient, because we're going to start easy. For this ingredient, we have its name, the quantity inside this hook that is called conditionally, so not at the top level, and this, whether it needs to be purchased. We're going to display this value and to add a button to add an ingredient. The first thing you've got to know is that the first time we run our app, React is going to create this virtual tree made of our React components. This tree is called the fiber tree. The fiber tree holds all of the components that make up our app and their data, their hooks and props value. This way, when a render happens, React remembers these values and knows which components it has to render. And from this fiber tree, React is going to inject our HTML elements into the DOM to display our application on the screen. So let's build this fiber tree together. The first component we instantiate is this recipe component with this JSX syntax. And JSX is actually just syntactic sugar, and is equivalent to the call of this function called JSX. And this function, when it is called, creates a new fiber. It's a node in our fiber tree. This recipe fiber is kind of like the instance of our component that holds the data of our component through vendors, its props and hooks values. This is the first node of our tree. It's our starting point. So we're going to start there. We're going to render recipe. What does this mean? Rendering a component simply means executing it. So we're going to execute this function. First, we have this useState. useState is going to be writing its default value into the fiber. Then, ingredient is null, so we don't pass this condition. So we move on to this second useState that also writes its value in the fiber. Hooks write their value in the fiber in a linked list, where every value points towards the next one. They write their value in the order in which they're called. Great. Then we move on to this JSX. We're using the JSX syntax here, equivalent to the JSX function that creates fibers. So we are going to create fibers for the paragraph, the input, and the button. And this is our tree. Now, this tree is still virtual. We haven't displayed anything on the screen yet. So what React's going to do is it is going to go through our fiber tree. And every time it encounters an HTML element, it is going to inject it into the DOM. And now our application is live. Things ran pretty smoothly, even though we use this hook conditionally. But wait. Wait till we click this ingredient button. We trigger a set state. What happens then? We are going to render. We are going to calculate a new version of our fiber tree that corresponds to the change that we've made, to our new render, our new state. Then React will be able to compare this new tree to the one from the previous render and apply the differences to the DOM. So let's calculate this new tree together, step by step. We click this button. We trigger this set state. So we update this hook value. And we are going to go through our tree and re-render the components we have to. So we begin with recipe. We render recipe, so we execute this function, and we pass it the hooks and props value coming from the fiber. First, useState is going to be reading its value from the fiber. Hooks read their value in the order in which they're called. So first, ingredient is going to be reading the first element of the linked list, flour. This time we do pass this condition. Ingredient is not null anymore. So we've got the second useState, quantity, that is going to be reading into the second element of the linked list. So quantity is going to be false. Then we've got this third useState, purchase, that can't seem to find its value anywhere. And this is when you get this way too familiar error message. Hooks store their value in a linked list where every value points toward the next one. They're all interconnected in this linked list. So if you call a hook conditionally, you change the order, you break your app. This is what happens if you break this first rule of hook. Only call hooks at the top level. Now, as you can see, this hook is very much linked to implementation details of React, details that may change. So rules of hooks, they may be kind of volatile. But rules of React, the one that govern the compiler that you've heard about today, they are here to stay. So before we tackle this second rule of hooks, let's talk about a few of rules of React. First, components and hooks must be pure. One simple way of making a component not pure is to mutate a hook value it uses. So this ingredient array, if we push a new element to it, we mutate it, what happens then? Well, we do update this value, but that's pretty much all we're doing. We won't see our new value on the screen. Because what makes the value appear on the screen is not changing this value. It's not even rendering this component. It happens afterwards. React goes through our tree, creates a new one, re-renders our components. Then, from this new tree, it commits the changes to the DOM. Then you can see your changes. And all this inner mechanic, that's something that you can trigger with the setState function, not on your own. That's another rule of React. React calls your components. You don't. We are also told not to use a setState unconditionally in render. That's kind of a cryptic way to say, don't do this. You know why this is bad. You render a component, trigger a setState, so render it again, over and over again, until you get this error message that I know you know. I know we've all triggered it at some point. Instead, you can do something like this. You can call a setState as long as it's conditional, as long as you don't trigger an infinite loop. OK, enough about rules of React. Let's go back to our React rules of hooks and tackle this second rule of hooks. And to break this one, only use hooks from React functions, so function components and other hooks. To break this one, we're going to go into the wonderful world of React Native. Our recipe is now going to have several ingredients that we're going to display in a flat list. A flat list, just like a text, is a core component provided by React Native. A flat list acts kind of like a map. You provide it with an array of elements and the render functions. It is going to map over our array of elements and call this render function for each of them to display it on the screen. So let's build a fiber tree. We've got recipe that we render, so we've got this state, this array of eggs and flour, and we create this flat list fiber because of the JSX syntax. We're done with recipe, so we can move on to the next fiber of our tree, flat lists. We render flat lists, so it is going to map over the ingredients and calls this render ingredient function for each of them. So it first calls this function with eggs, so we create this text fiber because of the JSX syntax, and with flour. And this is our tree. Now, if you try this out, you may see that this does not exactly reflect reality, because flat list is actually a class component, not a function component. So a few things are different there. And also, the flat list instantiates lots of other components under the hoods. So this is kind of different, but the idea will still stand. OK, so let's break our rule. To break it, we're going to add another functionality to our app. We now want the user to be able to set the quantity of each ingredient. But what if, instead of adding this quantity use state inside a regular render React function like we're supposed to, what if we add it inside this render ingredient function? Render ingredient is no function component. It's just a regular function. The difference is that when flatlist calls render ingredient, it calls it this way, as a function, not as a function component, not with the JSX syntax. and this changes everything. When the flat list is rendered, it is going to call the render ingredient function twice. First with eggs, so we execute this function. We've got this use state that is going to be writing its default value inside the fiber that's currently being focused, which is flat list. So we've got this 0 quantity inside this flat list fiber. Then the flat list calls render ingredient with flour. So we've got the second use state in there. So we end up with this tree, with the quantity values stored inside the flat list, where they don't belong. And from this code, with the use states stored below this render ingredient function, this is definitely not the tree that I would have pictured. Instead, if we had properly added our state inside an ingredient component that we call with this JSX syntax, the tree would be much different. When the flat list is rendered, it will call the render function first with eggs, so we would have this ingredient fiber because of the JSX syntax, and then with flour. Now we're done rendering the flat list, so we move on to the next fiber in our tree, this ingredient fiber. We execute this function component, and we pass it this props value eggs. We've got this use state that writes its default value inside the currently focused fiber, which this time is this ingredient fiber. And the same goes for flour. And this tree, to my opinion, makes way more sense. Now, if we come back to our very, very poor example with this use state inside this render function, is doing this really that bad? I mean, this tree is virtual, nobody sees it. But it can actually make your application crash. If we add this add ingredient button to add a last-minute ingredient to our recipe, if you click this button, you will actually make your application crash. Can you see why? When we click this button, we add this salt ingredient right here. So much so that when the flat list is rendered, it is going to call this render ingredient function 3 times. First with eggs, we execute this function. We've got this use state that reads the first element right here. Then with flour, so the use state reads into the second element. And do you see this coming? A 3rd time for salt. That can't seem to find its value anywhere. And we fall into the same error we encountered when breaking the first rule of hooks. We're basically adding a 3rd hook in there. So why does this work with the correct version? With the state inside a component, why does this work? When we click this button, when the flat list is rendered, it is going to call the render ingredient function 3 times. First with eggs, then with flour, and then with salt. So it instantiates this new ingredient fiber. We're done with flat lists, so we move on to the next fiber ingredient. Use state reads its value from here. Same goes for flour. And when we reach salt, this use state sees that this fiber is an amount state, not in a render state like flat list is, like all of the other fibers are. So it knows it has to write its default value into the fiber instead of trying to read it from the fiber. And this is what happens if you break React rules of hooks. React can sometimes seem magic, but it really is just an algorithm that you can learn and master. Of course, React algorithm is changing. So as much as I love understanding how the tool that I use work and why I have to follow the rules that I do, what's important is not so much knowing how the React algorithm works today with all of these details of implementations, because they will much likely change. What's important is more knowing why following these rules helps you write better code. Thank you so much.